Alright, calculus students, this is Mr. L here. We're going to go ahead and check out this differential equation. Figured I'd play a little music for you here. So, you got your differential equation. You got to sketch a slope field. It says, hey, just worry about where x isn't 0, and we can do that. So just look at some of these points, right? Like look at this one. Okay, that's the ordered pair, 2, 2. So that's 2, 2, and you plug 2, 2 into your slope finder, your differential equation. You're going to get 2 minus 1 over 2 squared is 1 over 4. So you need a slope of 1/4 there, which like, oh, how do I do a slope of 1/4? That would be like rise 1 and run 4. But you can back this up, you know, go back down 1 and back 4. 1, 2, 3, 4. So if I were going to connect those points with a line, because I always struggle with how steep do I make it. So imagine if you connected this point and this point with a line, the line would look something like that. So the slope of that line, that's the slope that you need to have going through this point. Okay, so when you put that mark on there, and you're not going to have to be exact, but come on, we're mathematicians, we want to be close. So that's a slope of 1/4. Pick this one here. Okay, that's the point 2, 1. So that's 1 minus 1 over 4, 0. Oh, that's a slope of 0. So you know what? I got a slope of 0 there. And if I look at this thing, whenever y is 1, x will be 0 as long as x isn't 0. So 0, 0. So, okay, you got a couple more to go. Let's go with this guy right here. Over 1 up 2. Over 1 up 2. So, plug it into your differential equation. X is 1, y is 2. 2 minus 1 over 1 squared. That's 1. That's 1. Slope is 1. So, down 1 over 1. You're looking at that slope. Okay, we're almost there. Cranking through it. Let's look at this guy right here. That's x is 2, y is 0. X is 2, y is 0. So that's negative 1/4. Down 1 over 4. Or back 1. Down 1 over 4. So up 1, back 4. 1, 2, 3, 4. So if you connected, this point with the one you're working with, you know what would the slope of that line there is negative 1/4. So you're looking at, I don't know, it should go about like that. Yeah. So put them all in the same color. Okay. This point here. Okay, x is 1, y is 0. So that's slope of negative 1. Well, this line would have a slope of negative 1. Alright, we're killing it. Negative 1, 2. Negative 1, 2. X is negative 1. So the bottom's going to be 1. And the top is 2 minus 1 is 1. Slope is 1. Slope is 1. Okay, so far so good. Now let's go here. Negative 1, 0. X is negative 1, y is 0. So you get negative 1 over 1, negative 1. Boom. Okay, you just did your slope field. Right? So as I look at this slope field, there's definitely, you know, y, let's see, x can't be 0. So you certainly have like this kind of thing going on here, some sort of discontinuity in your graph, your vertical asymptote or something. But yeah, I kind of like to look at these and try to get an idea of what does this graph, what does it look like? just from looking at the differential equation. I talked with some of you about, imagine if you dropped, if these are all currents in the water, and if you dropped something in here, well, their initial condition is when x is 2, y is 0. So if you drop something in the water right there, what does it look like? Well, to me it kind of looks like, the graph's going to look like this. Looks like it's going to go down like that. Kind of something like that. That's not part of your sketch on your slope field, but I'm just saying as you go through and you solve your differential equation, you could always check your answer that way. So we're going to just hammer out this algebra real quick. So you got your differential equation, and you're going to use separation of variables. So dy dx equals y minus 1 over x squared. Okay, I'm going to go multiply by dx on both sides. You go away, and then I'm going to divide or multiply both sides, I like division, by 1 over y minus 1. 1 over y minus 1. We're cruising. So, be smart, okay? Left side is 1 over y minus 1 dy. The right side, okay? I'm going to go x to the negative 2 dx, because you're thinking ahead. That's going to be easier, I think. So, now, variables are separated. Integrate both sides. Alright, the left side, natural log, absolute value of y minus 1. I'm not going to put plus c, I'll do it on the other side. This is negative 1x, negative 1 plus c. Cool. Alright, cruising. Next page. Copy. Paste. Okay, we're going to exponentiate both sides. Right, you're going to get rid of the natural log function. So you got absolute value of y minus 1 equals, now split this up, right? You got to use properties of exponents. X to the a plus b is x to the a times x to the b. We'll talk about why we want to do that. So you got e to the negative 1 x negative 1 times e to the c. Now, why would you want to do that? Well, now I have a great opportunity. Look at this, e to the c. How much do you think that is? Oh, by the way, that's just c. That's just a constant. So you're going to rewrite this. You go c times e to the negative 1x to the negative 1. So the reason I would do that is, look at how much better this step is. Right? It's cleaner. So by separating that exponent, alright, now we got that little trick right. If I said the absolute value of u equals 5, how much is u? U is plus or minus 5. So you strip off absolute value, you're going to slap plus or minus on the other side. Plus or minus c e to the negative 1x negative 1. Okay, cool. Now, oh, how much do you suppose that is? That's just c. Cool. C e, let's write this as negative 1 over x plus 1 equals y. Sweet, now we got the initial condition. We just got to plug it in. F of 2 is 0. F of 2 equals 0. They ask for a particular solution, not a general, so you're going to have to get rid of c. So that says, hey, by the way, when x is 2, y is 0. Y is 0. X is 2. So you got negative 1. So we got 0 equals c times e to the negative 1/2 plus 1. Okay. 0. We can move the 1 over. So we got negative 1 equals c times e to the negative 1/2. So just isolate c. Right now, c is being multiplied by e to the negative 1/2. So we can just divide both sides by this quantity. So don't freak out. I mean, I know it's not nice looking, but you can just divide it off. E to the negative 1/2. E negative 1/2. Oh, well, so you got e to the negative 1/2. That's on the bottom. I can move that up to the top. That's negative 1 e to the positive 1/2 equals c, or negative 1 times the square root of e equals c. Awesome. So now we just got to go back and we're going to plug this in. So let's go back. You found c. Now you got to go back right here. We're going to plug it in. So we just rewrite it. Y equals negative square root e times e to the negative 1 over x. Which is fine. Honestly, if you stop there, it's fine. Here's how they have the answer in the solutions guide. Oh, and we had a +1 there. Yeah, +1. Yeah, sweet, you did it. Now here's how it looks in the solutions guide, and don't panic, it's the same thing. They have it as y equals, or f of x equals 1 minus e to the 1/2 minus 1 over x. Those are identical. So no worries, you did it. It's good. I think the last thing that I might do, and not that the problem asks for, is we should check out this. Or this one. Right? Graph them. Because I told you what I thought it looked like on the slope field. I told you I thought it looked like that blue thing. So I'm going to attempt to graph this real quick with my super awesome graphing software on my PC. We're looking for a program called Grapher. Grapher? Maybe? I was hoping. Evidently I don't have Grapher on here. Oh, I really wanted to graph that and show you that it looked the same, but I don't see it on here. Oh well. Okay. So we did it. You sketched the slope field, and you solved the differential equation. Yeah, I'm just looking at your scoring guide here. You separate the variables, you anti-differentiate, include the constant, use the initial condition, and you solve for y. So, hey, as you look at this, one final thing I'll say is, and it's kind of not really a trick, but consider that graph, right? What's the domain of that function, right? Well, you should say x can't be 0. So the domain of that was from negative infinity to 0, union with 0 to infinity. Now you're going to have to pick one. Okay, so you just found a differential equation. Which of those intervals, contains your initial condition? Well, your initial condition said that, hey, when x is 2, y is 0. So it contains this. So, hey, this is the function we built. And by the way, x has to be greater than 0. Okay, so that's kind of a fine detail, but just when you do solve a differential equation, you need to pay attention to, okay, well, what is the domain of my differential equation? And if it's multiple intervals, you're going to have to pick which interval you're using your solution for. So, and all that you pay attention to is, well, which of those intervals, the subintervals, which does my initial condition fit in? Well, we said ours fit in 0 to infinity, which meant x was greater than 0. So, nicely done. You guys are awesome. Under 15 minutes.